Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the structure of the atom. In our previous lesson, we discussed the discovery of the electron by J.J. Thomson and the cathode ray experiments that led to that discovery. We also established that electrons are negatively charged particles. They are one of the three constituents of an atom. Today, we will be looking at the discovery of the second constituent of the atom, which is called the nucleus. Let us get started. In 1895, a German physicist named Wilhelm Röntgen made a very important observation as he experimented with cathode ray tubes. Röntgen noticed that cathode rays caused glass and metals to emit another, very unusual kind of ray. These rays were able to penetrate matter, traveling through different substances. Tests were then conducted with photographic plates, which are plates designed to darken when exposed to light. It was discovered that even without direct exposure to the cathode ray, they were blackened. Additionally, placing certain materials within range of these suspicious rays caused them to glow or fluoresce. These rays could not be deflected by a magnet, which meant that they were not composed of charged particles. This discovery positively identified them as being something other than cathode rays. Röntgen called them X-rays. The discovery of the X-ray led to research all over the world. In Paris, a professor of physics named Antoine Becquerel began to study the fluorescent properties of substances. Becquerel exposed heavily covered photographic plates to a uranium compound, which caused them to darken, even though no cathode rays were present in the experiment. Like X-rays, the rays from the compound were highly energetic and could not be deflected by a magnet. What was also important was the fact that these rays were generated without interference, meaning the uranium compound was emitting these rays on its own. A student of Becquerel's, named Marie Curie, gave a name to this phenomena. We know it today as radioactivity. Any element that spontaneously emits radiation is said to be radioactive. Students, let us do an activity. In your own words, define radioactivity. You may begin.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. How did that go? I am sure you were able to explain the basic idea, but the definition is as follows. Radioactivity is a phenomenon that involves the emission of radiant energy and highly energetic small particles of a substance, which can travel through a medium or space. If your answer included these points, great job! Becquerel's research into radiation revealed that 3 types of rays are produced by the breakdown or decay of radioactive substances, such as uranium. These rays are called alpha, beta, and gamma rays. Alpha rays consist of positively charged particles called alpha particles. This means they are deflected by plates with a positive charge. Beta rays consist of beta particles. These beta particles are electrons of a nuclear origin that are deflected by negatively charged plates. The third type, gamma rays, are unaffected by an external magnetic or electric field. After these discoveries have been made, research continued on the behavior of radioactivity. This led to an experiment in 1911, conducted by Ernest Rutherford and his 2 associates, Hans Geiger and Ernest Marsden. It was called the gold foil experiment. This is a demonstration of Rutherford's gold foil experiment. In this experiment, a piece of thin gold foil was bombarded with alpha particles, which are positively charged. He presumed that the mass and charge were distributed evenly throughout the atoms of the gold foil. Rutherford and his associates simply expected most of the alpha particles to pass through the foil. The results of the experiment were contrary to what Rutherford expected. Not only was the deflection of these alpha particles much more dramatic than they anticipated, in some cases, these alpha particles were reflected back at the source. Rutherford concluded that the reason the alpha particles were redirected was that of a powerful force that existed within the atom. The force could not be too big, because if it were, it would redirect all the particles fired on the gold foil. Instead, the force had to be caused by a densely packed bundle of matter with a positive electric charge in the center of the atom. Rutherford called this small, positively charged bundle of matter the nucleus. Students, let us finish the lesson with an activity. What was Becquerel's major discovery? What was Rutherford's major discovery?
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. I trust this was not too difficult for you. Antoine Becquerel's major discovery was the existence of the phenomena called radioactivity. This discovery led to the discovery of radiation and, therefore, the 3 different types of waves emitted in radiation. These discoveries led to the gold foil experiment conducted by Rutherford. Rutherford's experiment led to the discovery of the nucleus. Because of this discovery, Rutherford is often called the father of modern atomic theory. This concludes today's lesson. We learned about the discovery of the X-ray, which led to the study of radiation and radioactivity. We also learned about Rutherford's gold foil experiment and his discovery of the nucleus. In our next lesson, we will learn how these discoveries were important to finding out about the final constituent of the atom, the neutron. Until next time, thank you, teacher. Thank you, students.